Hello, today we are going to use Eclipse CDT C++ development tooling integrated development environment for programming for KDE, the KDE community. So the Eclipse CDT project is part of the Eclipse project. They're at version 11.5. The next version will be 11.6. There's both a Eclipse plugin, this one, and also a language server protocol. Eclipse Integrated Development Environment project is a 22 years old project, has integrated development environments for many programming languages. This is part of the list. There's also the Java graphical user interface widget toolkit SWT. There's also additional technologies in the Eclipse project, such as rich client reporting, web-based integrated development environments, Visual Studio Code-like environment, integrated development environments, etc. Eclipse Foundation. Let's download Eclipse CDT. Let's see how we can download this thing. Downloads. Okay, it took us to the official GitHub project, which is github.com/eclipse-cdt project group. The two GitHub projects are CDT and CDT LSP. We're going with CDT. And then releases. And then it says that we could use the Eclipse IDE installer, which is a graphical user interface application where you select what integrated development environments you want to install on your machine, and then it will download all of the needed Java runtime environments, Eclipse frameworks, and many plugins, OSGI plugins. I could not get this one to work because of HTTPS mirror issues. Next up, I'm trying the pre-built tarballs. Okay, so we're at eclipse.org/download/packages. This is for the latest public release of the Eclipse IDE, which is 2024-03. And the third possible download here is Eclipse IDE for C++ developers. I'm on Linux. Okay, it's downloading it from a mirror. We'll be back in a second. Okay, the download has finished. This is the file. It's a 360 megabytes tarball, tar.gz extension. I'm going to extract it. The usual way to extract it from the command line is with the command line tar space -xzvf, but you can also use your graphical user interface file manager, for instance. Let's try to actually use that. Okay, so it's just a directory that contains everything, including the Java runtime environment and many Eclipse OSGI plugins. these files with extensions jar and with reverse DNS notation and then a version in the name. Okay, so what we want is this directory, we want to put it somewhere. Or software which normally you would install on the entire machine, not per user, into /opt. When I install such software per one user, I'm going to use ~/.opt. Let's move the directory. And I'm also going to change the name of the directory to Eclipse-CDT. Let's see what's inside. There's just one executable, this one, Eclipse without any extensions. Let's look at the properties. Permissions, chmod bit executable is set, which means that we can start it by just double clicking on it. Okay, first up, the Eclipse integrated development environments use a concept of Eclipse workspaces, which is similar to a solution in Visual Studio, but in Visual Studio you open SLN files, which might be many on your computer, whereas the Eclipse workspace, you should have a very limited number of them. And you don't really put source code inside of this directory. Okay, so this is the first run of Eclipse CDT, Integrated Development Environment. It's showing the welcome page. In the left hand side, you have the tool window for Project Explorer. First of all, we'll need to build a KDE Git repository, but we're going to use CMake with a generator that's suited for Eclipse CDT. Let's see what that thing is. So CMake Eclipse CDT generator. There's 4 possibilities: Eclipse CDT for Ninja, Eclipse CDT Unix makefiles, and these two are probably for Windows, MinGW and NMake. So I have the KDE build framework, kdesrc-build installed. Let's see how that thing looks like. So there's an executable which is called kdesrc-build and a configuration file. Let's look at it. Okay, all of the values in here are defaults, except the fact that I have changed the CMake generator to be Eclipse CDT4 Unix makefiles, and Eclipse CDT Ninja also works correctly. So just pick one of these two, Eclipse CDT Unix makefiles or Eclipse CDT Ninja. Then I'm going to build software using kdesrc-build. Let's build kcalc. After that worked correctly, next I have used such a command line where I build just the kcalc KDE Git repository with this parameter no include dependencies. I'm not doing any Git operations. I'm doing a full build, and I'm using ---- debug, which means that the output should be as verbose as possible. We can see in here it did make install in here. This one, gmake install/fast. Before that, it did build, which is gmake -j16. Before that, it has run the CMake configure step. It's using Qt6. Next up, let's look at the directories that have been generated for kcalc by kdesrc-build. So there's the directory /kd/src kcalc. This is just a git clone, nothing else. There's no files which are unstaged or staged. The working folder of the Git repository, local directory, points to the local Git master branch and to the remote origin master branch, which means that it's just a Git clone, nothing else, no files have been changed in here. All of the files that are generated by CMake, by GNU make, by Qt, so the MOC, UE, UIC, and RCC executables, everything happens in /kd/build kcalc in here. And this is the directory that we actually want to open in CDT. The steps are like this. From the Eclipse CDT main menu, File, Import, and existing projects into Workspace. Next, I paste in here at select root directory the path, the full path of the directory where kdesrc-build has built files for kcalc. Then I need to select the browse button, which determines that this directory exists on the hard disk and looks inside of it recursively. Not really. If you enable the option search for nested projects. And it has found that this directory was generated by CMake, and we're using the CMake build configuration debug. This is what's showing the name of the KDE Git repository, then minus, this is the CMake build configuration and the directory. Nothing else to select in here, finish. Okay, let's look and see if building works correctly. Project, build project, or this build button in the main toolbar. It was really fast. It's not a rebuild, it's a build. It still does some things because it's using GNU make, not Ninja. Okay, but it builds correctly, that's important. Next up, let's see a rebuild. How do we do that? How do we do a clean? I'm not sure what it did, if it only did a clean or a clean and then a build, because it did a ton of things. I know. Project, and then we want to build. Let's see this button. So it was really fast, which means that it actually, the previous step where I did clean, it actually did a rebuild, not just the clean. So it did make clean and then make. Okay, let's look at the directory structure. So in tilde/kd/build/kcalc, there should be a bin directory. In there are the executable files, such as kcalc. We can double click on it. Why does it work correctly? It works correctly because we've provided a full path to the executable when we started, and the location full path of the SO files, share object files, is hard-coded inside of the executables. We do not need to specify LD library path. So the application kcalc has been compiled correctly, and then we can run it from the tilde/kd/build/kcalc/bin directory. The make install step will take this executable and put it into its final destination, which is tilde/kd/usr/bin directory. But when we're exercising the debugger, we're actually not doing make install. So we leave in this directory. Okay. The second button on the toolbar, it says that we can either run without the debugger or run with the debugger a CMake build target. We can select one, just kcalc. Okay, let's see if it runs correctly. And no says that no executable file is specified. Okay, let's see how we overcome that. In Project Explorer, we expand the only project that's loaded, which is kcalc. In here, there's top level directories for binaries, which is a view into this directory. Then there's the source directory, which is a view into this directory. Like this. And we're going to select under kcalc binaries kcalc to run kcalc. So right click on it, run as local C++ application, and it's started correctly. We can also start the debugger, right click on kcalc, debug as local C++ application. Eclipse integrated development environments have this concept of Eclipse perspectives. There's usually two perspectives, one for editing and the other one for debugging. We'll try to see how the Eclipse perspective for debugging looks like. So I go switch when we start the debugging. The Eclipse perspective switcher is this toolbar. Let's lock the toolbars. So this one says open perspective, C++. So this is the text editing Eclipse perspective, and debug, which is the debug Eclipse perspective. Now we're inside the debug Eclipse perspective. We can see that this is a toggle button and it's currently toggled. Okay, the debugger has started and it has stopped on the first line where it could stop. So this is the entry point of the executable, the main function, C++ function. It has stopped on line 2833. We could put a breakpoint in here, but there's no need. Let's actually do it. So from the Eclipse CDT main menu, run, and then toggle breakpoint, Shift, Control B. Okay. Now we have a Eclipse tool window named breakpoints, where we can see the list of breakpoints. We can delete one, we can delete all of them. There's a tool window for local variables. This is the one for watching expressions. And this is one which shows the threads and call stacks, and the fact that it's using the GDB GNU debugger for connecting to the running application. Okay, let's, in the main toolbar, the icons have changed a bit. Instead of the run icon, now on the second position there's the debug icon. In the combo box, not run is selected but debug. And the run configuration is named kcal, not kcal-debug at kcal. Let's look at the shortcuts. Run, so resume is go to the next breakpoint or exit if there's no other breakpoints. Step into F5, step over F6, step out F7. I don't really know these shortcuts, so I'm going to use the keyboard keys mapping for Visual Studio. Let's see how we do that. Window, main menu in Eclipse CDT, preferences, search for key, and under keys, scheme, Microsoft Visual Studio, apply and close. Okay, and now the shortcuts are a bit more familiar. Resume F5, step into F11, step over F10, step out, Shift F11. We have these also as buttons in the main toolbar in the Eclipse debug perspective. So step over. Probably it works too intensively with GDB, the debugger in CDT. Maybe it asks a ton of data from GDB. It's both slow and sometimes the connection with GDB will crash, and also it will step into wrong places, although I'm not building the C++ modules with any optimizations. I'm building them using the CMake build configuration debug. So expect to need to stop the debugger and start it again when things don't work correctly inside of the debugger. Or wait a bit. Minutes. Okay, step over. Let's see if it knows how to step into. So this is a static function. Step into. Should go to kcrash.cpp in tilde/kd/src kcrash directory, which it did. What is this? It's an integer. Unfortunately, the visualizers for QString and other fundamental Qt types doesn't work out of the box. So there's visualization with a mouse over. You can also use expressions. Just drag and drop the expression. Add watch expression. So select an expression and then go right click and add watch expression. Okay, let's use the shortcut. So F10 and F11, Shift F11, so F10. Q environment variable is set. Let's see if we can step into this thing. F11. So we have built Qt6 using kdesrc-build and using the debug CMake build configuration. So we have access while the debugger is running. The debugger knows how to step into all of the CPP files from the Qt framework. F11. This is a C++ template. And templates have the body, the implementation usually in .h files. So it's just calling the standard C library function getenv. Okay, let's see if we can exit this function. So step out. It does work. Step over. It has stepped into the somewhere which I did not actually ask. I'm not sure why it steps in here. Shift F11. Okay, F10. So it evaluates all of the parameters, arguments of the constructor k_about_data. And then it's actually going to call the constructor. Let's see if we can go inside of the constructor using F11. No. Step out. Step in. No. Step out. Step over. Step in. No. Step out. Step in. We want to step inside k_about_data CPP inside of the body of the implementation of the constructor. Nope, we're inside Qt. Step out. Step over. So it takes, I don't know, 20 step overs in order to actually go to the next line, which is 2853. And we did not enter the constructor. Okay. It complains the Eclipse CDT IDE that it cannot find these headers, but it definitely can find them because we're using kdesrc-build and that's calling CMake and that's using the CMake generator for this version of CDT. We can see that in the settings of the current project. So from the Eclipse CDT main menu project and then properties. In C++ include paths. We have include paths that point into everywhere. So for C locale, it's this one, /usr/include/c++13. For k_about_data, it's I know which one. One of these with tilde/kd/usr/include/kf6. For KXML GUI factory, that's this one, tilde/kd/usr/include/kf6/kxml GUI. So Eclipse CDT knows in which directory these files exist, but it still says that the unresolved inclusion. If you try to navigate to it, it fails to navigate. Wrong button. But after a while, under I do not know which circumstances, things start to work way better. So you can navigate to half of the symbols with control click. Let's continue debugging. Let's tap into the static method set application data. We're in the correct place. CPB file, key about data from tilde/k. Where are you? Where is the tooltip? This one, tilde/kd/src/k core add-ons. There is visualizers for structs and for objects, instances of type class. Sometimes you will see these white empty lines. This is when the CDT is talking to GDB, to the debugger, to find the list of children of this symbol, in this case static meta object. And I can hear the CPU fan starting. Let's put a breakpoint in here. On toggle breakpoint and go resume F5. And it's going to take a while because it's still trying to fetch data from GDB instead of trying to go to the next line. So instead of doing step over. Okay, so you either have a ton of patience or you can just stop the debugger somehow. So probably the communication with between CDT and GDB is single-threaded and blocking non-asynchronous. That's what I guess. It's not blocking the main UI of Eclipse IDE, but it's certainly blocking the only communication with the external process GDB. Okay, and now we can start because we have the breakpoints in the correct places. We can just start debugging. So again, you can change between debug and run without debugging in this combo box. You can start the debugger from this button. You can start the debugger from this button, from the main menu, run, and then debug. It stopped on the first breakpoint. We have 2 breakpoints. We're going to go to the next one, F5. And GDB is fast, but then integrations on top of GDB should make sure to ask for little data from GDB. Should be frugal in interrogating values of local variables, of members of the local, of this, of self, of the current object, and other information. Okay, let's see if toggle source header works. And it does, to the correct directory, ~kd/srck core add-ons. Let's look at the call stack in here. Works. Step out. It can navigate to the files inside of this Git repository. So we have two navigations. There's the navigation that happens when you're not running the debugger and you're using the integrated development environment support for navigating, which means right-click, open declaration, control-click, control-click on a symbol in the CPP file, on the implementation of a symbol to go to the .h file where the definition, declaration of the symbol exists, and then back again. It can navigate to some members of the current object, but sometimes it cannot, so I'm not exactly sure what this randomness. It can go to set colors, navigate back, but it cannot go to set base font. Maybe this is an inherited method, who knows. Okay, so that's about what we have in here. The big limitation is that we don't have visualizers for QString, at least if we don't have for the queued containers. And the debugger seems to work okay, but you need to consider the fact that you don't want to overwhelm GDB. So make sure you're frugal when you're debugging. Navigating during the debugger works great because then we're not actually using the integrated development environment to navigate when we, for instance, step into, but we're using GDB, and that works correctly. And then there's all sorts of squigglies in here, which maybe you can improve somehow. The source code builds correctly, debugger works correctly, you can run without debugger correctly, but the overall functionality when you're not in the debugger is not Great. Okay, so that's about it. The key points are that you want to use the specialized CMake generator for CDT4. We can see that the version of CDT is 4. In here it says, where is it? So the Eclipse CDT version is 11, but it's still from the CDT4 major version. Let's close the project and reopen everything as fast as possible and do a quick run. Okay, so this is the Project Explorer. This is showing the contents of the Eclipse workspace. We're going to clean up the Eclipse workspace, so right click on the project, delete. We don't want to delete the actually tilde/kd/src/kcalc directory or tilde/kd/build/kcalc directory. We're just going to remove the reference to the kcalc project from tilde/eclipse-workspace. That's it. Okay, now we can see that there's no projects loaded in our workspace. We can go File, Close All Editors. Let's reopen CDT. You could either navigate to tilde/.op/eclipse-CDT and start Eclipse from here, or you can start it from the command line. So tilde/.opt. There's auto-completion in here and Eclipse. Don't forget to put the ampersand at the end. You're probably going to use either the same Eclipse workspace all of the time or a small number of Eclipse workspaces. Launch. And now we're going to import the existing project. Let's actually recreate the kcalc directory. So we're not going to work into tilde/kd/src/kcalc. This is just a clean git clone. Instead, we're going to delete the tilde/kd/build/kcalc directory. Then I'm going to do a thorough rebuild using this command line. kdesrc-build kcalc -no src, no include dependencies, refresh, build, debug. So that was the CMake configure step. This is the build step. And once build is 100%, it will start the make install step, which takes files from here, from tilde/kd/build kconfig directory, and put them into tilde/kd/usr directory. Everything's done. We could use this link inside of the Project Explorer tool window, import projects, existing projects into workspace. Next, it remembered the last directory that we provided in here. It's correct. We go finish. And then we go straight to build. Build should be successful. It's not going to rerun the CMake configure step, so there's no need to specify the fact that we're using tilde/kd, not /usr for the source directory, for the build directory, for the make install directory. And it's fast because it's just doing a build, not a rebuild. If you just run, it's not going to know what to run. It's going to run the Git repository. So you're going to expand in Project Explorer the project and binaries, go right click on kcalc and run as local C++ application. What that does is that it creates in here a second launch configuration named exactly as the executable, so kcalc. And now it will not complain that it doesn't know which executable to run. Or you could use this button, the edit CC++ configuration. Or there's this button in the Eclipse CDT main menu, run, and then under run or under debug, you go to run configurations or debug configurations. It's the same thing. And if you don't have this configuration created automatically, it's going to be automatically created when you go right click on one of the executables and go run or debug as local C++ application. It is created in here automatically for you. But if not, you can go the hard way and create the run configuration yourself. So that's done in the main menu, run configurations, delete the existing run configuration under C, C++ application. So we're not using Docker, container, remote SSH, etc. We're using the simplest thing which we could use, which is C, C++ application. Then it asks that you click on this button, new launch configuration. You name it something, not key number test, kcalc, executable, for instance. In here you can select projects. There's just one project in the current Eclipse workspace, so you select that. Then you can select the executable, which is on this button, search project. We're going to select kcalc. Okay. So this is enumerating CMake targets of type executable. Okay. And then your executable might require additional environment variables. For instance, if you're running a QML application, then you will need at least 3 environment variables in here. Those environment variables you can get from here. So these are the values that you want to put in here. Let's see how that is done. Apply. Open a text editor. Paste in there the contents of prefix.sh. And let's do what's saying in here. Sure how to actually do it. So the path environment variable needs to have values prepended. Since we did build using -refresh build and -debug, we know the expanded values of these variables without the dot path. Or we could ask the shell to expand them for us. Like this. LD library path we do not need to specify because we're using our path. So the full path to the s.so files is included inside of the executable kcalc. Let's see, for instance, this one. So there's just this part. X, Control V. Not needed for simple Qt widget applications, but for QML applications, you're going to need each and every of these environment variables. Otherwise, it will not be able to find QML modules, QML themes, etc. Okay, apply. We can start the running automatically by clicking on the run button or not. And now we can find it in here in this combo box in the main toolbar. We select kcalc executable. We select the fact that we want to, run but not debug, and then click on the run button. Okay, when we want to debug, select the fact that we want to debug and click on the debug button. And it should stop automatically at the first line. Let's see these two tests, so executables, CMake build targets, but of type CMake test, ctest, qtest. Let's see this one. Right click, debug as local C++ application. A new launch configuration has been created automatically. This one, kcalc parser core test. The debugger is running. We can see it in here. Click on the two X buttons. It's showing that there's still activity and it's still attached with the debugger. And it's stopped somewhere because you can see that the resume F5 button in the main toolbar is enabled. You double click on the only thread that's expanded on the core stack, and we're at line 258, which is the entry point, which is the main function, C++ function of this executable. Okay, let's put a breakpoint somewhere. For instance, here and here, and then resume. Okay, so it ran many tests and it stopped on line 225. And from here, the usual step over and step into. String to token queue. What is that? Clever. This thing, kcalc parser string to token queue. Okay, so in case you don't have a better integrated development environment, the debugger experience in Eclipse CDT is almost okayish for my tastes. But then, for me, the fact that Eclipse CDT doesn't have visualizers for inside of the debugger for QString and other Qt types, that's a deal breaker for me, because the integrated development environment from the Qt framework, which is named Qt Creator, does have such a thing. And also the experience when I'm not running inside the debugger is better, because Qt Creator does not have these issues where it cannot see symbols that it totally can see. Let's now uninstall Eclipse CDT, Integrated Development Environment for C++. First of all, I'm going to close all of the windows. So we go close all editors from the file main menu of Eclipse. Then I'm going to remove from the workspace all of the projects. That's right click and then delete. Don't delete contents. Okay. We should also stop the debugger if it's running. This 2x icon means that tasks that have been finished and are still being shown in a Eclipse tool window will be removed from that tool window. Close the application. And now let's find out all of the directories where Eclipse has put files. So only my home directory is modified. This is where I have downloaded the installer. This is the directory where I have installed ~/.opt eclipse -cdt. Shift delete. So I'm not moving the files to the trash recycle bin, but I'm actually deleting them. Next up in the home directory, there's the workspace, ~/eclipse -workspace. Then there's the Eclipse, the hidden directories .eclipse, .p2, .swt. What else? In the cache ~/.cache directory, there's Eclipse and Eclipse installer directories. These are the directories that you can easily see, but then maybe there are some hidden files and directories somewhere. I'm searching for Eclipse mainly. So in ~/.config, I don't see anything interesting. .local share. Yes, Eclipse. .opt I have already done. And that's it. No traces of Eclipse CDT should exist on my machine. Thank you.